data encoding techniques we discuss, we need to convert signals to transmit, right? So the data we need to convert into signals. Now, when we talk about data, we know that data is represented in binary. So we need to way of converting these data into signal format, right? Now, there are many ways that we could do this. Now, first one is we call it non-return to zero level, which means we will use two different voltage levels for 0 and 1. For example, this one we will say low voltage, this is high voltage, right? So that's what we are going to do. So each of the time we have low voltage, 0, and whenever it's 1, it changes to high, again to low, again to high, again to low, again to high. It's still 1, right? So this is high, then again low, low, high, high. So non-zero to non-return to zero level, it's easier. So whenever you have voltages, we can use two ways. Then there are many others. The next one that we have looked at is called non-return to zero inverter. In this particular case, what will happen? Right? In this particular case, what will happen? So in one is represented by a transition, 0 is without any transition. So you start with something, right? So let's say low. If it is a 1, then it's going to change. That's all you need to remember. So you have low, this is high. 0 means no change. So you continue like this. When you say 1, it will change high to low, right? Then it's 0. 0 means no change. It will go like this. Whenever 1, you have to change. So that means this is low. It will become high. Again, you have 1. 1 means a change. So it will high to low. Then we will have 0, no change. 0, no change. When you see 1, it will go from low to high, right? Again, there's a 1, then high to low. Okay. Third one, we call Manchester encoding. The voltage changes from low to high or high to low in the middle of the signal, right? So in this particular case, you will see, let's say 0. Let's assume that it's go from 0 to, high to low. Then 1 means low to high. Again, 0 means high to low. 1 means low to high. 0, high to low. Then 1 means low to high. Again 1, low to high. So 0 means high to low, high to low, low to high, low to high, right? So signal changes in the middle of this. This is the middle of the signal. So you will see here, all the other cases, if you go back, so it's the end of this value, but here it will happen in the middle. Right. Any questions? Nimesha, Shashmi? පුතේ නොතේරුණු තැනක් තියෙනවද මේ signals අපි හදන විදිහ? ඒ කියන්නේ data අපි දැනට දන්නවා binary විදිහට යන්නේ කියලා. But we need to convert it to some signal form. So what we form here is a digital signals, assuming you have low voltage and high voltages. Is it clear to you? So during O levels, we discuss computers, we have digital signals. Telephone lines, we have analog signals. We convert digital to analog and then analog to digital. So this is exactly what we are trying to discuss here. So digital data, that means ones and zeros, we are going to convert into signals. Then we can put it into telephone lines, for example. Right. So last time we end with the error detections. Now we know that when you transmit signals throughout some medium, that might distort, maybe change, right? So let's assume that this is one of our signals. Now we know, assuming that this is low is 0 and this is 1, this is like 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, like this. But what will happen, you send this message and then we are going to receive this message, right? Now we know that there's an error here. So this is originally low, but it has changed to high. So which means we are now going to discuss how can we identify any error here, right? So what happens if you find any error, you are going to ask the source to send the signal again. So that's how is the idea, right? Error correction might be one issue, but so there's an error in the received signal. So this may be due to external noises, or maybe getting the data corrupted. Sometimes the data is corrupted when you send from one place to another. Right, let's take down this. I think we have not discussed this earlier. This may be due to external noises and getting data corrupted. Right. Now we discuss how there might be any errors. Now let's look at how we are going to correct them. Right. Let's write down the process of identifying the error identify that there is a error in the received signal is known as error detection. Right? The process of identify. Now we send this signal, but we receive this signal and there's an error. So if we can identify that there's an error, this whole process is known as error detection. Then to correct the data, and to recover actual bits. Error correction, right? So first of all, we need to identify whether there's an error. And the next one is we need to correct it if possible, because otherwise you have to ask the signal again, right? You have to ask the sender to send the signal again. Right. Now there are many ways that you can identify any errors in the system. But the simplest one we call parity check, right? We will say parity check. So when you say parity check, right, we are going to use the data is received accurately. So there will be a bit we use for this, we call parity check. And under that, there are two ways. The two ways are we call even parity and odd parity, right? So when you say even parity, when you receive the bits, you add them up, right? And you are going to see whether it's even, right? This parity bit we going to decide based on the existing values, right? So depend on what existing values, you are going to decide on the parity. Okay. Okay, I think let me explain this with an example. So let's write down parity check. Let's write down parity check. This is one of the simplest error detection method, which uses an additional bit of the data which uses an additional bit of the data to make the data is even parity or odd parity. Right. So let me give you an example. So I'm going to talk about the parity, right? Right. So don't take down. We'll start with the parity and the data to represent character E. Let me put it to table. Right. Let me start with the table. Right. So this is what I'm going to do. Don't take down. I'm going to take parity first. That means I told you there are two methods. Parity, first of all, I'm going to say even parity. The technique we are going to use to detect any errors. I'm going to say parity check, even parity. Or the other one we call odd parity, right? Then the second one, I'm going to get some data. Let's say data to represent character A in ASCII. Do you remember how ASCII is used? Can one of you tell me how we are going to use ASCII? In parity bit. Encoded data to be set. Remarks. Right. Yes. Himasha, can you tell me how we discuss how to represent A in ASCII? Do you remember? Yes. How do you represent ASCII? Don't remember now? ASCII? Forgot? About Shashmi? How do you represent capital A? Yes. Okay. So it's 65 if you remember the decimal equivalent value using 7 bits. If you do not remember, I will put a mark. In ASCII, uses 7 bits to represent characters. The decimal equivalent value for A is 65. We already know this, but I will put this because, right. How do you represent 65? We have, yes, 1, 2, 4, 8, 16, 32, 64. So 64 plus 1, right? So that means the data is this 1, 0, 0, 0, 0, 0, 1, right? Tunai hatarai hatai. Isn't it? So this is how we represent A using 7 bits. Similarly, same data, we are going to use the other technique. Right. Now here is it works. Now this is what we want to send, but we are going to make the number to even parity. When you add all the bits together, we should get an even number. Now for that, we are going to use parity bit. Now, if you add all the numbers together, Nimansha, what is the value we are getting here? When you add all the numbers together, what is the value we are getting? When you say 1 plus 0 plus 0 plus 0 plus 0 plus 0 plus 1, what is the answer?
2.
It's 2. 2, is it an even number or is it an odd number? 2, number 2, is it an even number or is it an odd number? Nimansha?
Even.
It's even. So since the numbers are even, then the parity bit we are going to use is 0. I'm going to put this in red color, right? The parity is 0. Why? When you add the original data, it's even. So parity bit, we are going to decide 0, 1 based on the value we are getting. Since we are getting even, we put 0. So when you encode, this is how we are going to send 1, 0, 0, 0, 0, 0, 1. Right? And the parity bit is added to the front like this. Parity is added to the front like this. So what we are using is this, right? Now, what do you need to remember when you received it? Yes, when you receive it, you just check values. You check the value. if the number is right, when you add the numbers together, and when you add the numbers together, you get the numbers when you add numbers together, and the value is even number, then there is no errors according to even parity, right? Even parity. Right. Now I would like to give the chance to Shashmi. Now let's say we are going to go for odd parity. Now, when you say odd parity, when you add everything together, we are expecting to have odd numbers. So when you add all these numbers together, what is the value, Shashmi, we are getting? Shashmi?
Two.
Yeah, it's we are still getting 2. Is it even or is it odd?
Even number.
It's even number. Now to get an even number, what should be our parity bit? Now we are getting 2. So how to make you parity bit could be 0 and 1. But to get odd number, what is the number we have to put it here? Is it 0? Is it 1? To get an odd number.
1.
Yeah, we have to put 1 here. Now, when you put 1, we have 1 plus 1, 2 plus 1, 3. So this is the parity bit. Now, if you're using odd parity, this is the data you are going to send, right? And this is called parity bit. Right. Now I will give you some examples. Right? Can you take down this now? First of all, take down, then I will give you some exercise. Finished? If you taken down this one, please let me know. So we can pause. Ada putala?
Okay, sir.
Right. Okay. So let me give you some examples. I want you to try, right? Right. Now, can you find out whether there's this one, whether it's comply with the even parity, or last one, whether it's comply with the odd parity? Let's shall we discuss the answer? Finished? හරිද පුතේ? උත්තරේ වහගත්තද? බලන්න මේ data එක හම්බෙච්ච එක එකතු කරලා බලන්න ඒක even or odd දෙන්නේ කියලා දීලා තියෙන අගයත් එක්ක. ඒක දීලා තියෙන අගයට අනුකූල නම් error එකක් නැහැ no කියලා දාන්න error එකක් නම් yes කියලා දාන්න. Right, let's start. නිමේෂ මට පළවෙනි එකට උත්තරේ කියන්න. error ද yes ද no ද? අපිට හම්බෙච්ච data එක තමයි දීලා තියෙන්නේ. ඒ data එකේ මෙන්න මෙහෙම ඇවිල්ලා තියෙනවා. අපි දැන්ට කතා කරන්නේ ඉස්සරහම තියෙන එක තමයි parity bit කියලා කියන්නේ. අහන්නේ even parity detection method එකෙන් ගියොත් if you go for the even parity one, is it an error or no? Yes or no? Yes. Shashmi?
No.
Yes, there's no error. Why? When you add up everything, it becomes 2. 2 means even parity. So there's no error. Okay. Next one, Nimesha. Yes, Nimesha. Is it an odd parity or even parity?
Yes.
Calculate everything. When you add everything, 1 plus 1 plus 0, 0, 0, 0 plus 1. Actually, you can add only once. So what is the value we are getting? Nimesha?
2.
Yes, it's 3, right? You add everything together. පළවෙනි එකත් එක්ක. ඔව් පළවෙනි එකත් එක්ක පුතේ. අපි පළවෙනි එක decide කරේ ඒක දාලානේ. හරි? මේ දැන් data receive කරපු එක. Right? So when you say 1 plus 1 plus 1, it's 3. But we are expecting the even parity. So because of that, there's error. කොතනද වැරදිලා ඇත්තේ? කොතනද වැරදිලා?
Yes කියලා තමයි.
එහෙම කියන්න බෑ. මේ ඕන එකක් වෙන්න පුළුවන්. අපිට ඕකෙදි වෙන්න පුළුවන් error තමයි. එක කියලා තිබ්බ තැනත් බිංදුව උනත් වෙන්න පුළුවන්. බිංදුව කියන තැන එක වෙලා එන්නත් පුළුවන්. එහෙනම් අපි දන්නවා error එකක් කියලා. හැබැයි කොතනද error එක කියන්නේ අපිට තව තියෙනවා ක්‍රම අඳුර ගන්න. ශෂ්මි තුන්වෙනි එක third one. Yes, this is odd parity. So we have 1 plus 1, 2. So 2 is not odd. Because of that, there's error. There's an error. Right? We'll do more examples, but just to give you an idea like what parity bit is. Okay, so with that one, we come to finishing of 6.3, section 6.3. So what we have discussed in 6.3, right? we discussed some of the signal properties. We would like to discuss what signal properties. And then how to represent data using voltage levels. Manchester encoding we discuss, right? And then parity bit we discuss, how to detect a bit level error, right? So that part we have discussed under 6.3. So let's move on to the next one. Now in this one, we are going to look at about public switch telephone network, right? Because it's early days, all the telephone lines work with this one, right? So let's write down. This is 6.4, public switch. Right, let's write down. This is a interconnected network of telephone line. It connects telephones with a single wire without connecting each and every telephones together. Right, I will explain. Now this is an international interconnected, it should be an interconnected network of telephone lines. So basically PSTN means the network we are going to create by combining the telephone lines, right? And it connects telephone with a single wire. Okay, you might think very early days, that means in the beginning of these telephones. So when you want to make a connection from, let's say, point A to point B, so that means we have to have a dedicated, line for that. So if you're going to do this, it will not be that easy because everyone needs a separate line. So that's what PSTN facilitates. So public switch telephone network means it will connect each and every telephones together, right? And then you don't have to have separate wires for everyone. Right. The main objective Right, there are many devices which connect this, right? Copper telephone cable, definitely, especially if you're connecting fixed telephone to another one, we are using telephone lines. But then if you want to connect towns, we can use fiber. Okay. Let's have a very simple diagram. Right. Okay. So basically, this network is for voice networks. And this is exactly what we had in early days. Hello. Okay. So you know about the telephone network. Do you have a fixed telephone at your home? අපේ SLT ෆෝන් එකක් තියෙනවද පුතලගේ ගෙදර?
ඔව්.
තියෙනවා. තියෙනවා නම් මේක දන්නවා. දැන් ඒක කොහෙටද කනෙක්ට් වෙලා තියෙන්නේ පුතේ? පුතාලගේ ෆෝන් එක ඒ කනුවට කනෙක්ට් වෙලා තියෙනවනේ. ඒක ගිහිල්ලා කොහෙටද කනෙක්ට් වෙලා ඇත්තේ? ඔව්. කනුවට කනෙක්ට් වෙලා කියලා නම් දන්නවනේ. අපි කියනවා මෙහෙමයි. දැන් පුතාලගේ ෆෝන් එක කණුවට කනෙක්ට් වෙනවා. හැබැයි කණුවේ තියෙන අපි කියන ලූප්ස් තියෙනවා කියලා. ඒකට කියන්නේ ඩිස්ට්‍රිබියුෂන් පොයින්ට්. එහෙම නැත්නම් DP කියලා. සමහරට එක 5ක් 10ක් විතර වෙන්න පුළුවන්. හරි? එතන ඉඳන් තමයි එන්නේ. ඒකත් සම්බන්ධ වෙලා තියෙන මේන් අපි කියනවා ඩිස්ට්‍රිබියුෂන් ෆ්‍රේම් කියලා. ඒක හරහා තමයි මේ අපි කියන මේන් එක්ස්චේන්ජ් එකට සම්බන්ධ වෙන්නේ. එක්ස්චේන්ජ් කියලා එකක් තියෙනවා. ඒ එක්ස්චේන්ජ් කියන එකට සම්බන්ධ වෙන එක හරහා. අපි PSTN ලයින් එකක් ගත්තොත් අපේ ඒකේ ටෙලිෆෝන් කනොට් ටික තියෙනවා. right? ඩිස්ට්‍රිබියුෂන් පොයින්ට් එක තියෙනවා පුතේ. අපි ගත්තොත් ඕකේ කොහොමද එන්නේ කියලා ඩිස්ට්‍රිබියුෂන් පොයින්ට් එක තියෙනවා. right? අන්තිමට ගත්තාම එක්ස්චේන්ජ් කියන එකකුත් තියෙනවා. හරි. එක්ස්චේන්ජ් එකකුත් තියෙනවා. right. උතරත් මම ඒක පින්තූරයක් පෙන්නන්න. අපි දල වශයෙන් ඇඳගමු මේ විභාගයට අහන ඒවා නෙමෙයි. නමුත් මේවා දකින්න තියෙනවා පුතේ ඔයගොල්ලෝ බැලුවොත් එහෙම. හරි? මම දල වශයෙන් ඇඳ ගන්න ගොඩ මේ විස්තර අඳ ගන්න ඕනේ නේ. අපේ සාමාන්‍යයෙන් තියෙන දේවල් තමයි telephone line එක ගෙදර තියෙනවා නම් if you have a telephone at home it will connect to one of the posts and that cable is connectly mainly the DP we call distribution point අපි සිංහලෙන් කියන loops තියෙන තැන කියලා ඔකට ගිහිල්ලා ඔතන තමයි හදන්නේ ගොඩක් වෙලා right if something goes wrong in your home telephone they are looking at this distribution point and up to this point cable goes from overhead lines උඩින් තමයි යන්නේ හරි එහෙම ගිහිල්ලා එක තැනකින් මේ කේබල් යනවා underground හරි එතකොට මේ underground වල දුර යද්දි මේ කේබල් කනෙක්ට් වෙන තැන් තියෙන ඒවට අපි කියනවා cabinets කියලා ඊට පස්සේ ඒක ප්‍රධාන තැනකට සම්බන්ධ වෙනවා අපි කියනවා main distribution frame කියලා ඒක මෙයා වෙනවා පොතේ exchange එක කියලා exchange එක කියලා දෙන එතනින් තමයි අපි කෝල් එක ඒ අවශ්‍ය තැනට නියමිත ආකාරයට වෙන් කරලා යවන්නේ. ඒතර මේක තමයි දල වශයෙන් අපිට network diagram එක කියන්න ඕනේ. මේකේ නම් ටික මම type කරන්නම් පැහැදිලි නැති නිසා ඇඳගමු අපි මේක. So this is called exchange. So here we have underground lines. This is overhead lines. This is called cabinet. And last one, this. ඒක තමයි main distribution frame කියලා තියෙන්නේ. එතන DP කියලා එකක් තියෙනවා distribution point. මෙන්න මෙතන තමයි අර මම කිව්වේ. ආවනේ පුතලගේ ගෙදර කනෙක්ෂන් එක වැඩ කරන්නේ නැත්නම් right? So these are the labeling we will have. That's how the network works. Okay, විභාගේ පැත්තේ නම් මේක මතක තියාගන්න ඕනේ නැහැ කියලා. right. ඇතගෙන ඉවරන පුතේ කියන අපි මේකේ වෙන විදිහ ලියාගමු. Right. So that's about the telephone network. We just need to remember that it's actually consists of, connecting multiple telephones together, but not using dedicated wires. Now for that, we will, create what we call PSTN network. Right. So the next topic is modulation, demodulation, and model. Let's discuss about this now. right. පොතේ ඔය ටික ලියලා ඉවරනම් මට මැසේජ් එකක් දාන්න මම එතනින් කන්ටිනියු කරන්න. Modulation, right? Now, altogether, we discussed the idea of modulation, but we are going to look at, according to this one, right now, we need to discuss about the modem as well. So we are going to discuss modulation and demodulation related to the modem, not in general. Because if you remember, we discussed modulation earlier, that when you want to send a signal, you are going to combine with another signal, which we call carrier signal, right? So we discussed there are different ways. You can have continuous wave modulation, you can have pulse modulation, amplitude modulation, and so on. We discuss multiple ways of modulating this, right? So, but in this case, we are going to discuss so using modem, we can actually convert back and forth, which means when you want to send the data out from computer, so computer uses digital signals, and when you want to send data out, we need to convert into analog. So modem can be used to convert digital to analog. We call modulation. And once you receive the other end, we have to demodulate. Demodulate means, yes, then analog to, we need to convert digital, right? So the modem, the name actually made up of the first few letters in modulation and then demodulation, right? Okay, let's write down that one then. In modems, the modulation means to convert digital signal into analog. Then demodulation means to convert analog digital. Right? Modulation means you convert digital signals to analog signals. Modulation. And demodulation means to convert analog signals to digital signals. Therefore, modem will convert digital signals, analog and analog. The model will convert digital signals to analog signals and analog signals to digital. So converting digital to analog, we said modulation. So we get mod from here. And analog signal to digital signals, we call it demodulation. Demodulation. Right. Let's move on to the next one. If we start from digital form, so the data in the computer, we have digital form. And then when you want to transmit data, we convert into analog through a telephone wire system. So let's draw simple figure representing this one. So let's draw this figure roughly. So what happens here, computer, we have digital signals, and then you convert these digital signals to analog. So this is what the modem does, right? So then you can, now we know that when you have very high frequent signals, you can easily transfer data from one point to another one. So the analog signal received by this modem to be used this within the computers, we have to again convert it to digital form. Right? So let's write down this. Okay. So with that one, we will finish 6.4. So in 6.4, what we discuss is PSTN network. PSTN stands for Public Switch Telephone Network. Then we discuss modulation, demodulation, and with modems. Right. Okay. Finished? Can you message me whether you have finished or not? So let's move on to the next one. In the next one, we are going to discuss what is already we have done, right? That's about the network topology, right? So if you remember, right, what are the topology? What is topology? What is topology? Remember topology? Nimesha? Shashmi? What is topology?
It refers to layout of a computer network.
Yes, exactly. Now, physically, how you are going to create a network. This is exactly what is we are going to discuss, right? It's a network. So network, how we are going to physically set up a network is called network topologies. Okay, what are the topologies you should know?
Bus topology, ring topology,
Okay,
star, star topology,
okay. What else? Mesh topology and
mesh.
yes, tree topology. So we have already, done these ones. Yes, and it's not that difficult, right? Right. So let's write down. So we call it how computers are connected together physically, right? How computers are physically connected one another, we call network topology. Right. Let's start. Right. Let's first start with the bus topology. You said bus topology, right? So what do you mean by bus topology? Yes. What do you mean by bus topology? Yes. What do you mean by bus topology? You don't remember bus topology? So in bus topology, what happened? It will connect to into one main wire. Remember? We call there will be a main wire. In bus topology, computers are connected to one main wire. Let's write down. One main wire. Main wire with terminators at the end. All the computers in a network are connected to one main wire, and there are terminals at the end.